Dear viewers, greetings. I hope everyone is doing great. Are you ready to learn? So let's start. The viewers who has watched the previous video, they know where this video is going for new one. I am attaching the link for the previous video just to make a connection and link how we are going to study material science in this series. So let's dive into material science. Model is one of the earlier consequences of quantum mechanics. Here, this image shows a schematic representation of Bohr's model. Bohr told us that the energies of electrons are quantized. It means electrons possess some specific values of energy, and these energies may be accompanied with energy levels. And here he explained the model for allowed state of hydrogen atom. Let's see how it works. He has proposed a mathematical formula for the energy state where we can give the values of n, and then we can find the energy levels in this model. The interesting fact, energy is always going to be a negative number. Why so? Because the energy of an electron in orbit is relative to the energy of an electron which is separated from the nucleus. Hence, n is equal to infinity according to this formula, which is defined as to have an energy of 0 electron volt. And since an electron in orbit around the nucleus is more stable than an electron that is infinitely far away from the nucleus, so energy of an electron in orbit is always negative. Atomic model came into existence because Bohr's model failed to explain several phenomena involving electrons. So according to a wave mechanical model, an electron has wave-like and particle-like characteristic, where Bohr just explained a particle-like characteristic of electron. Here, the important thing is the electrons are no longer treated as particles moving in discrete orbitals, but rather position of electron is considered as the probability around the nucleus. Here, if you see this diagram where we have the probability according to wave mechanical atomic model to find the electron around the nucleus, and if we plot a graph between the distance from nucleus to electron, there is a probability going from a scale from 0 to 1, and if you see the maximum probability of finding an electron correspond to somewhere around nucleus, and in this way we can understand how electrons are not in quantized states here, but they can find in some space around the nucleus in terms of probability, which represent the wave nature of electrons. Into wave mechanics, every electron in an atom is characterized by 4 parameters which are known as quantum numbers, and they are represented by these letters N, L, ML and MS, where N stands for principal quantum number, which represent the shell around the nucleus where electron can lie. N is equal to 1 correspond to K shell, N is equal to 2 correspond to L shell, and so on with the 3M, with 4N, and you can find the principal quantum number which shell is there around the nucleus. And L corresponds to subshells like S, P, D and F. ML is the number of energy states for each subshell. And there, if you see for an S subshell, there is a single energy state, where for P there are 3 energy states, for D there are 5, and for F there are 7 energy states exist respectively. However, under the application of magnetic field, these subshells split, and we assume each state has a slightly different energy. With each electron, there is a spin moment associated with it, and it must be oriented either up or down. So there is the fourth quantum number come into existence, which have two positive values, plus half and minus half, one for each of the spin orientations. And if we look at this table, it tells us principal quantum number. Let's, as we have discussed previously, n is equal to 1 correspond to K shell, which has the further subshell S. And according to the third quantum number, it has number of state 1. And if we go to the fourth quantum number, how these number of electrons are distributed per subshell and per shell, then you can see with this information we can get an information about the number of shells, about the number of states, about the number of electrons lie in every subshell. And this other image is a representation of the relative energies of the electrons for various shells and subshells when we plot it between the principal quantum number and the energy. So till now we got the information about electron states, how the energy values are permitted for electrons. Now, to determine the manner in which these states are filled, like how we arrange the electrons in these states, there is a rule which is known as Pauli's exclusion principle, and according to this principle, each electron state can hold a maximum of 2 electrons, which must have opposite spins. In this way, each subshell can accommodate a particular amount of electrons. For example, for S, there will be maximum 2 electrons. For P subshell, there will be 6 electrons maximum. For D subshell, there will be 10 electrons. And for F subshell, there will be 14 electrons. And the electronic configuration gives us the information how these states are occupied. It is interesting to tell here, like when I was in school, I didn't understand this concept for the first time. But as far as I studied and I asked so many questions to my teachers, I was able to understand how it works. And I hope this video is also going to help you in the same way. So what is the ground state? Ground state is the energy state or energy level where all the electrons occupy the lowest possible energies according to the rules we have discussed. And the valence electrons, they are significant part of an atom which lies in the outermost shell of an atom. And it takes part in bonding, in chemical interaction with other atoms of other elements. Here in this table we can see the electronic configuration for some of the common elements. If you look at this table carefully, for hydrogen there is hydrogen has atomic number 1. So according to its electronic configuration is 1s1. 1 is the principal quantum number, s is the subshell, and 1 which is on the superscript represent the number of electrons present in the hydrogen atom. And same if you see for the helium, the number of electrons in S subshell is 2. For lithium, the number of electrons is 3, and so on. In this way, you can understand how these rules are followed to fulfill the electronic state, or how the electrons are arranged in an nucleus. And I think personally I feel all of these arrangement makes it interesting, like every rule they are following, and what a beautiful result we are seeing in this table. And this is all about how science works and keep our life interesting. So interesting thing which is called the periodic table, and it first came into existence by a Russian scientist Dmitry Mendeleev. He tried to arrange the elements according to their properties. So in this periodic table, we have 18 groups and 7 periods. And also the modern periodic table is managed by the International Union of Pure and Applied Chemistry, as you can see here. How beautiful it is. Here you can see the elements are arranged according to increasing atomic number in 7 horizontal rows, which I already told you called periods. And this arrangement of elements are arranged in such a way like they are having a similar valence electron structure as well as chemical and physical properties. You can see the inert gases which have like completely filled subshells. You can see rare earths, actinides. I think you can read more about online about all these elements. It will be helpful for you. Again, I want to say you thanks everyone who is watching. Please like, subscribe and share my channel. And there is one correction from my previous video. The book we are following through these videos where the atomic weight is expressed in atomic mass unit per atom.